All right, so today we're looking at solving multi-step equations. If you recall from our last lesson where we were solving equations, we used the same two steps. Step one being to simplify the equation by combining like terms on each side. And then step two is to apply inverse operations to continue solving the equation. We're going to be using PEMDAS backwards. All right, our first example goes back to your classwork on Friday. A lot of you were having issues with problem number 10 in the classwork, and it involved a fraction in front of the parentheses. And we have some steps for this example. It says step one, apply the multiplicative inverse to remove the fraction. Step two says we simplify. So what does that look like? We have 4 is equal to 2/3 times x plus 3. And we want to take the multiplicative inverse of that fraction. That would be 3 over 2. So we're multiplying by 3 over 2. What we do to one side, we have to again do to the other side. So we have times 3 over 2 on the left-hand side. We know on the right-hand side, because of the multiplicative inverse, we know that's going to cancel out. It's going to be equal to 1. And we're left with x plus 3. Again, if you look at this, it's 3 times 2 will give you 6 at the top, and then 2 times 3 will give you 6 at the bottom, and 6 over 6 is just equal to 1. So they cancel out. On the other side, we have 3 times 4, which is 12 over 2, which is going to give us 6. Now we're left with a one-step equation. We have 6 is equal to x plus 3. To solve for our variable, we need to isolate it. So instead of adding 3, I'm going to take the inverse and subtract 3. What I do to one side, I have to do to the other. So because of the additive inverse, I know that the 3's cancel out, and x is going to be equal to 6 minus 3, which is 3. The answer to example 1 is x is equal to 3. All right, so let's look at our checkpoint. I'm going to erase this and give us space. I'm going to work out checkpoint B because a few of you were having issues with that. We have a negative 3 over 5 times the quantity x plus 1 is equal to 9. We know we're going to use the multiplicative inverse, but keep in mind that that fraction is negative, so we have to use a negative reciprocal. So we have a negative 5 over 3 times a negative 3 over 5 times the quantity x plus 1 is equal to 9. Remember, what I do to one side, I have to do to the other side. So we're going to multiply that 5 over 3 on the other side also. We know that a negative times a negative is going to yield us that positive 1. So here these cancel out, and we're left with x plus 1 is equal to, if I simplify that, I get a negative 45 over 3. And a negative 45 over 3 will give me that negative 15. So I can take that off. I simplified that 9 times that negative 5 over 3 gives me a negative 15. Now to solve for our variable, we need to get rid of the 1. And I use the inverse property, so I subtract 1 on both sides. I'm left with x is equal to a negative 16. And that's our answer. Let's go ahead and look at our next example. In this example, we're looking at an equation that has variables on both sides of the equal sign. So you guys have some steps. It says step 1, we want to move all variables to one side. Now, I mentioned in class that you guys want to use the rule, when in doubt, move all variables to the left. So if we look at this, I have this 6x, I take the inverse, so it would be a negative 6x. What I do to one side, I'm going to subtract 6x to the other side. On the right-hand side, we know these cancel out. I'm left with a negative 8. This is equal to 9x minus 6x will give us 3x plus 10. And here, I'm left with a two-step equation. Now, to solve this two-step equation, remember we're following PEMDAS backwards. So I have to complete any addition or subtraction before I complete my multiplication or division. So here, I have to get rid of that positive 10. And the inverse of a positive 10 is a negative 10. So I'm going to subtract 10 from both sides. I'm left with 3x on the left-hand side is equal to a negative 18 because my 10s cancel out. Now here I have 3 times x. The inverse of that would be to divide by 3. What I do to one side, I have to do to the other. The 3's cancel out, and x will be equal to a negative 6. And this is our example 2. Now I'm going to work out one of these checkpoints. I think we're going to work out checkpoint 2 for you guys. Let's look at checkpoint 2. Or checkpoint 2A. So if we look at this, notice we have variables on both sides of that equal sign. Our rule says that when in doubt, move all variables to the left. So instead of subtracting 8, I'm going to add that 8x. And I'm going to add 8x to both sides. Now something interesting happens on the right-hand side. Because of the additive inverse, I have a negative 8x plus 8x. I know that they are going to cancel out, and they're going to be equal to 0. So I have 0 on the right. What about on the left? This negative 6x plus 8x will give me 2x plus 4. And here I'm left with a two-step equation. I need to solve for that variable using inverse operations. So instead of adding 4, I'm going to subtract 4. Again, what I do to one side, I have to do to the other. The 4's cancel out. I have 2x is equal to a negative 4. If I solve for x, I have 2 times x. The inverse is to divide by 2. And here my 2's cancel out, and x is equal to a negative 2. My answer for checkpoint number 2A is x is equal to a negative 2. If you guys are working out checkpoint B, we know that x was equal to 3. So see if you can come up with that answer. If we move on to example 3, example 3 is an example of some of the hardest problems that you'll see from this lesson. So if you can work out example 3, then you're doing good, because this is as hard as it gets. Now I've got 3 examples or 3 steps for this example. Step 1 says to simplify on each side of the equation. Step 1, simplify on each side of the equation. Step 2 says to move all variables to one side. Notice that you don't want to move those variables until you have simplified. Step 3 says to solve for the variable. So looking at those steps, if we look at this example, it says I've got to simplify. Well, I know that my expression is not simplified if I still have parentheses. So in order to get rid of those parentheses, I've got to distribute what's on the outside. So once I distribute, I have 2 times that 4x gives me 8x, and then 2 times the negative 3 gives me a negative 6, minus 8 is equal to 4 plus 2x. Now that I distribute the 2, notice that my parentheses have dropped. So I don't have any more parentheses. But I still need to simplify because I have like terms. So if I simplify, I have 8x minus 14 is equal to 4 plus 2x. And now I can tell that both on the left and the right of that equal sign, my expression is simplified. I cannot combine any more like terms. From here, I go to step 2. And it says move all variables to one side. When in doubt, move all variables to the left. So here I'm going to subtract that 2x from the right. What I do to one side, I have to do to the other. My positive 2x and negative 2x is going to cancel out on the right. I'm left with 4 is equal to 8x minus 2x gives me 6x minus 14. And now I'm left with a two-step equation. I need to solve for x. Remember, I'm following PEMDAS backwards, so I complete any addition or subtraction first. So I want to add 14 to both sides. When I add 14, that 14 cancels out. I'm left with 6x is equal to 18. From here, I have 6 times x. I know that the inverse of multiplication is division, so I divide by 6 on both sides, and therefore x is equal to 30. My answer for, we can pull that back up. My answer for example 3 will be x is equal to 3. Now you had 2 checkpoints after example 3. And they look like this. So we can go ahead and look at, we may go ahead and look at both of them. If we look at this first one, we know we need to simplify first. And we have a lot of parentheses here. So I have to distribute the outside terms. I have an outside term here. I must distribute. So 4 times 1 gives me 4 minus 4x. Plus 3x is going to be equal to, now I have to distribute that negative 2. I get negative 2x minus 2. Notice once I distribute those outside terms, I can drop my parentheses. But I'm still not finished. I still have some terms I can combine on the left-hand side. So I know that that negative 4x and positive 3x are like terms. So I can combine them. I have 4 minus x is equal to a negative 2x minus 2. From here, I've simplified on both sides of that equal sign. Now I can move my variables to one side. And remember, when in doubt, move all variables to the left. So here, instead of a negative 2x, I can have a positive 2x. What I do to one side, I do to the other. So the 2x's cancel out. I have a negative 2 is equal to 4 plus x, because a negative x plus 2x gives me 1x. And here I still need to solve for x. I'm still solving for x, so instead of adding 4, I need to subtract 4. What I do to one side, I have to do to the other. So once I subtract 4, the 4's cancel out, and I'm left with x is equal to a negative 6. So the answer for checkpoint number 3A is x is equal to negative 6. I think we're at 14 minutes. I'll go ahead and let you guys work out that next checkpoint. And this is our lesson for today on multi-step equations.